So we're going to take another look at Java classes in this session because the objects and classes within Java are an important part of the Java language. We'll need another session to look at all those other aspects of Java classes. So we're going to talk about some static class members, passing objects around into methods, returning objects from the methods, using the toString equal operators, and then methods that copy objects. Also, we'll talk about aggregation, how to use this reference variable, the concepts of mutable, immutable, enumerated types, the garbage collector, and then on class collaboration. So we're going to just do a quick review of what we learned so far in the previous session, that whenever we create an object from a class, we create an instance object, and each instance object has its own copy of the variables or attributes. So for example, when we created multiple instances of rectangle, each rectangle instance had their own individual values of length and width. Okay. Whenever you call an instance method, you must have an instance object in order to use those instance methods. And those instance methods can only interact with the instance data fields and invoke and calculate values based on those fields. It cannot use any static data members. And when we talk about now static data members, there are static function members, and then there are static data members or static fields. So for example, in this case here, there is a function of square root that exists on the class called math. Okay. So you can only use this method square root on a class level, not at the instance object level. Static fields, when they are defined in the class, they are defined with the static keyword. And then that means that each instance object will have its own copy of that variable. Those fields are initialized to 0 if they are primitive static fields. If they're objects, they're handled differently and they're set to null. So each instance variable will get initialized upon each object instance being instantiated. So here in a case, we have a static data member called of an integer type that keeps count of how many objects are being created of that type. So every time another objects get created, you can increment a static count, and it will increment this number every time another instance object that's created. And so every one of these objects can see and are related to this class static field. Static members similarly have the static keyword in the function header. And so it must have the static header in the method definition. And when you have these static members, it means that it cannot access any of the data that are at the object instance level. It can only access data members that are defined as static data members. So here, static functions can only access static fields or any other, or it can access variables that are passed in as parameters or any local parameters inside of the function. Another thing is about passing objects into as arguments into a function. So all objects are passed by value into the function, except for objects. So when objects are passed into a function, a pointer to that object is passed into the function, not the actual object. So here is a case where I pass a, a reference to an object box, which is of type rectangle, into a function called display rectangle. And this is merely just an address to the object of rectangle. And when you return objects from a method, it also is doing the same thing. It is passing a reference to the object. It is actually not passing the actual object. So here, when get account returns and returns an object, it is passing a reference of an object out. And then here you can see it being assigned into a variable. The toString can be called explicitly on any kind of object, and it gets called implicitly when the object is used in a print line statement like here. So here is a reference to a stock object, and when we include it here, it implicitly calls the toString method of stock. Okay. And here it's when you concatenate a string with the object, it also calls the toString method on the object. All objects, as soon as you define an object or a class and you try to invoke the toString method on it, it has a default behavior of passing the class name and a hash reference to the memory address of the object. And it may not mean a whole lot of value to you, but you can override the default implementation of toString and change that toString behavior. And when we call the equal method on objects, it is just comparing the address, the memory address of the object, not the actual content of the object. And so if you actually want to call and check and compare the content of the object, then you have to call the equal method on those objects. So here's an example of having two different objects. And when you do this kind of comparison here, this is just comparing the memory reference or memory address, and this would be then false, and it would come here. But if you actually wanted to compare the actual stock price and the stock symbol, then you would have to write your own equal method for that object and then do a comparison of the object symbol and the price. There's a missing parentheses right here. And then when you copy objects, when you just copy just the variable, you're just copying the address of that object into another variable. But if you want to copy the actual content, then you need to do something called a deep copy. So when we do the deep copy, we need to use copy constructors. So you need to create another constructor that takes the same object as an input parameter. And when you do that, then you individually copy every data field or data member from one object into the new object constructor. So here we're copying, this is a constructor for stock, and we're taking the symbol, assigning it into the new object's symbol data member, and doing the same thing for the price. So when we instantiate it like this, so we're instantiating with a regular constructor, and then here we are using the copy constructor or a deep copy. Aggregation is where one object contains multiple reference addresses to other objects. So here's a visual diagram that there is a course object, and it contains a reference to an instructor object, and then another reference to a textbook object. So this is considered an aggregation object, where again, one object contains one or more other object references. This is a best practice rule about avoiding to return references to private data members. So if you go back here, and if this is a private data member, of course, you do not want to return this data attribute to another um, outside class. It is being done here, but this is assuming that these are maybe public or non-private data members. So null references is a special thing within Java. So when we have a variable containing a reference to an object, but that variable has not yet been assigned to an address to an object, then it will be set to null. So until it is actually set to a object reference, that variable is null. So method chaining is a concept where if you have an object and they in turn have methods that return another object, and then they in turn have more methods on that object, you can chain these method calls together so that you can avoid having to do these each individual statements like this. So here, getting to the uppercase version of the instructor's name can be simplified in one statement that basically says course, get instructor, get the name, and then get the uppercase version of the name. So this is another representation of how this method chaining works. But to improve readability of the code, you want to make each one of these chained methods on separate lines.